All right, in this video, I'm going to continue to go over section 4.2. Okay, so, um, 4.3, I'm sorry. So we'll see a conditional probability, okay? And then complement, section 4.3 covers complement and conditional probability and Bayes theorem, but uh, this course we don't cover I'm not going to cover Bayes theorems, and then I'm going to cover just complement conditional probability, but we I did go over complement on the last video, so I'm going to cover conditional probability today, and then we're going to solve some problems to recap what we have learned in 4.2 and 4.3. So conditional probability, so the last time I introduced conditional probability briefly, right? So, but conditional probability means that probability of B bar A, that's the notation of conditional probability. And it means that probability that the event B occurred, given that event A is already occurred. So we assume that event A is already occurred. So then the, you know, the mathematically, then how can you calculate, how can you find out the probability? Just here, the formula. So P of A and B over P of A. Okay, so here the in probability, the meaning of this one is this. Normally in when you calculate the probability, we use classical probability. It means that the you know so here when you calculate P of B, that was is equal to number of the outcomes in event B divided by number of outcomes in sample space S, right? Here, capital letter S represents sample space, and then N parenthesis S means the number of outcome sample space, and the N parenthesis B means the number of outcomes in the event B. Okay, but see that here, let's compare this one, conditional probability, and then just probability of B. So this one expressing the that formula in the conditional probability in terms of the number of outcomes, then B bar A is going to be, see, number of outcomes in A and B. So it means the number, we're going to find the number of outcomes belong to both A and B. It's called common outcomes, right? Divided by, let's see, divided by number of outcomes in a event A. Okay. So then as you can see that, yeah, definitely the fraction and the those two fractions, okay, so fractions. See, the numerator is different, right? This is the number of outcomes B, but this is the number of outcomes in A and B, and then but the uh the important thing is this: the bottom one in the fraction, and bottom one is n of s in a P of B, but in conditional probability, bottom one is n of A. So it's kind of the sample space is reduced by the event A. Okay, and then you may wonder that why that one, this fraction, can be expressed as this one, because I skipped the one procedure, but actually P of A and B, there's about top one. This one is equal to what? The applying the classical probability. This is the n of A and B divided by what? N of S, number of outcome sample space. Okay, that's the P of A and B. And then the bottom one gonna be what? P of A gonna be number of outcomes in sample space A divided by number of outcomes in number of outcomes event A divided by number of sample space S. Okay, so this is a numerator over numerator. So in the back, that numerator, the numerator denominator is also fractions having, right? So and then simplifying this one, then we're gonna get this. Okay, we're gonna get this one. All right, so this is the kind of actual formula to figure out conditional probability. Okay, keep in mind this. Now then, let's see example right here. So the table below lists the result from pre-employment drug screen test right here. So find the probability that someone gets a positive test result given that they use drug. So um, now let's see that right here. Okay, so by the way, so before doing that, see now let's figure out the event. Okay, so find the probability that someone gets a positive test result given that they use drug. So let's say event A, say the event already occurred, which means that they use a drug. So say all the uh what screen test people use drug. Okay. Now then let's see. So then number of outcomes in event A gonna be what? How many people use drug, which is 50, right? So 44 plus 6, which is 50. Okay, so 44 plus 6, which is 50, right? And then let's say event B is the set of all the outcomes gets positive test result. Okay, which is 44 plus 9. Okay, so positive test result. So then NLB. Now, but actually we to find out probability, then define the probability that someone gets a positive test result given that they use drug gonna be conditional probability, right? B bar A, right? Okay, this is equal to number of outcomes. See that here? Number of outcomes in outcomes in A and B. So we need to figure out the total number of the screen test uh, belong to event A, event B, right? That means what? We gotta find figure out number of screen tests, get positive test result, and use drug, which is 44, right? Okay, so that's gonna be what? Number of outcomes in A and B, right? A and B, right? So now this is gonna be 44 divided by what? The number of outcomes in event A, which is 50, right? Okay. So now we just using calculator the figure out decimal expression of this fraction with 3 significant digit. Okay. So now then next problem, to find the probability that someone used drug given that they got a positive test result. So now here the what event has been given, which is the positive test result, right? It's positive test result. The number of outcomes in event A is going to be uh, the 44 plus 9, 90, 134. And event B is what? Find the what? Someone used drug. Okay, use drug. Okay, should be this one. Okay, so now then B bar A. Okay, it's gonna be. Okay, then we're gonna find out N, A, and B, right? So we figure out the number of outcomes belong to both A and B. The positive test result and you use the row, which is 44, right? We already figured out in this problem, a previous problem, right? So 44. Okay, divide by the how many outcomes in event A? Positive test result 134, right? 134. Okay. So now the next problem, find the probability that someone gets a negative test result given that they use drug. So let's say event A is a negative. They use drug. Okay, they use drug. Okay. B gonna be what? Negative test result. Okay. So by the way, how many the people use drug? So 50, right? Okay. So N of A 50. And then what? Probability, conditional probability of B bar A. It's going to be number of outcomes belong to A and B. Use drug, but negative test result is going to be what? 6, right? Okay. This many people use drug, but got negative test result. It's called the first test. This is called what? First negative result, test result. Okay. Pos Someone got positive test result even though they didn't use drug. It's gonna be what? This, false positive test result. Okay. So anyway, so back to problems. Conditional probability of B bar A gonna be what? 6/50, right? Okay. So and then last problems. A gonna be what? Let's see, they got positive test result. Positive test. Okay. And then also number of outcomes in event A gonna be what? Positive test result is 134, right? And then B is the event. Event B is the set of all the outcomes. I mean, but people, they don't use what? A drug. Okay, so which is the 90 plus 860, right? Okay, but we don't use that one. But anyway, so just not use drug. Okay, so PB bar A it's gonna be number of outcomes belong to A and B, positive test result, but they don't use drug, which is first positive test result, right? Which is 90, right? 90 divided by 134. Okay, so let me see, positive test result. Yep. Okay. So now the back to, let's see, the problems that I didn't cover, that problem. So let's see this example. The table below lists the result from a blood test. Okay. So here there are 4 blood type, right? O, A, and B, and AB, and then RH. Oh, and then include the plus 2 type, additional type, RH plus, RH minus. So if one person is randomly selected, find the probability of getting someone who is group O. Okay. Then what? Probability that O gonna be what? Is the number of outcomes in O, blood type O, divided by number of outcomes in sample space S. Now, how many the results in here in the table? So we add all the numbers, right? Okay. So here the number of outcomes in a sample space is gonna be 100. Okay. The number of outcomes in how many people has blood type O? 39 plus 6, right? Which is 45 divided by 100. And then you need to convert the fraction to decimal expression with just 3 significant digits. Okay. So now then, which is actually what? This is 0.45, right? Okay. So now then, next one, if one person is randomly selected, find the probability of getting someone who is not group O. Then P of O prime, right? The complement. That is, we use using rule for complement, which is 1 minus P of O, right? That's going to be 1 minus 0.45, which is point what 55, right? And if one person is randomly selected, find the probability of getting someone who is group O, or you see, or means what? Addition rule. Okay, type RH plus. So P of O, okay, or means union, okay, or RH plus. Okay, that is equal to, we use the addition rule, which is P of O plus P of RH plus minus P of O and RH plus. Okay, that's addition rule, right? So P of probability that the blood type, oh, we already figured out, which is 0.45, right? Plus probability RH plus gonna be what? How many blood type is RH plus? We add 39, 35, 8, 4, these 4 numbers. Okay. That's 86, right? So 86 divided by the 100, right? And the minus. So how many people the has the what blood type O and Rh plus? 39, right? This many people has blood type O and Rh plus. So 39 divided by 100. Okay. So then calculating this one is what? 0.45 plus 0.86 minus 0.39. Okay. So that's gonna be what? 0.82, right? 0.92. 92. Okay. So now next problem, last yeah, so we have two problems more. Okay, so if two different people are randomly selected without replacement, is it without replacement right there? So it means that we got to use a conditional probability. Find the probability that they both have type Rh minus. That is, the first one has Rh minus and the second one has Rh minus. Okay, so in this one, what? We don't use the formula. Yeah, you can use a formula of the what conditional probability. Okay, but the easy the, the easiest way is to figure out the probability for each event. Okay, what I mean is, so in the first trial, okay, we what we need to first trial we choose the people whose blood type is Rh minus. Okay, so let's say A is the that Rh minus. Okay. B is what? The second one has Rh minus. Okay. Then B bar A is equal to, right? First one, the we find the in the first try, first one we have to find the probability that the first trial we got the Rh minus, which is the how many people has Rh minus? The excuse me, 14, right? So 14 over 100 times. Okay, if uh two events are occurred consecutively, then we're gonna use multiplication. Okay, all right. So now then see what also the actually two events are not independent, right? Because without replacement, it means that event A effect on the probability that event B occurred. So two events are not independent. Okay. So now then the next one, since the first trial already occurred, it means that total number of the outcomes in sample space is going to be reduced by 99. Okay, something over 99, right? Okay. And then the since the first event A is already occurred, so number of people the what whose blood type Rh minus reduced by 13. Okay. One, of course, we picked the one people whose blood type Rh minus in event A. So and then we don't allow the replacement. So this is gonna be not 14 but 13. So here, okay, we just calculate it. So I got 0.184, 0.184 approximately. Okay. So now then, last problem. If three different people are randomly selected with replacement, is it with replacement? So then event A and event B, both events will not be affected each other. So two events are completely independent. So find the probability that they all have group AB. Okay. So now then, let's see. So in this case, event three people are randomly selected, right? So then three events A, B, C gonna be coupled, okay? So then find the probability that they all have group AB. Okay, so probability that, let's say A is the first one has AB, then B is the first, second one has AB, then C is equal to, C is the set of all the outcomes. The third one has blood type AB. Then probability A and what, B and C. Okay, so this is actually not B bar A, actually A and, okay, A and B. Sorry. So that's gonna be probability of A times probability that B bar A, which is equal to, okay. So 14 over 100 is a P of A, and the 13 over 9 I'm gonna P of B bar A. Okay. So this is equal to, let's see, that is equal to what? Since the three events are independent, we don't have to use a conditional probability right here. Okay, so we just simply P of A times P of B times P of C. Okay, which is equal to, how many people has blood type AB? 5, right? So 5 over 100. That's a probability that, first one has AB. This, see, replacement allowed. So when you select the second one, number of sample outcome sample space still 100, because once we select the first one and then check the blood type and then put it back to the sample space, that's what means with the replacement. Okay, so it's going to be 5 over 100 times 5 over 100, which is what, 0.05 to the third power. Okay, so I got the 1.25, the e minus 4. Okay, we got this. So yeah, so for for recap, I just solved these problems. Okay, so the key point is this: you need to be familiar with addition rule, multiplication rule, and the mutually exclusive, independence, and the conditional probability, and the rule per complement. Okay, so next time I'm gonna start section 4.4, counting. So we're gonna study several the way to count the number of outcomes event. Okay, let me stop here.